Hello and welcome. In this video, we're going to look at how to solve logarithmic equations. So we have this equation here with log base 2 of 6 is equal to x times log base 2 of 3 plus 1. The first thing you want to do when you're solving equations with logs, like this one here, is try to get all your bases to be the same. So in this example, we have log base of 2. So we have 2 here and 2 here. So they're the same, which is good. However, we have a plus 1, which isn't even a log yet. So we want to work on getting this into a log with base of 2. And we'll look at how to do that in just a second. And one thing I should note is that if you have log of, say, 8, and you don't have a base here, like we do with our 2 up here, then it is assumed that the base is 10. The other thing that is very important when you're solving logarithmic equations is that you know your log laws. So let's start out with this one. We want to solve for x. So with this problem up here, the first thing we want to do is rewrite it. And this time we want to have all of our logs with base of 2. Right now we have both of our logs with base 2, but we have a 1 on the end, which makes things difficult. So we want to make that into a log as well. And to do that, I'll write down our first log law that you should know. And that is log to the base of a number when that number is the same as the number in your bracket is equal to 1. So if we work backwards with our 1 here, we can do exactly what happened here. Because we have 1 and we want to get this 1 into a log. So that means that we can make this 1 into log, and then we have base, and then that same number we use for the base as our number in our brackets up here. And let's make that number 2, because remember, we're trying to get all of our bases to be the same, because that makes things a lot easier on us. So if we do log base 2 of 2, that is the same as our 1 up here, and we can rewrite the rest of our equation exactly the same. Okay, so that leaves us with this equation, and the only thing we have changed is making our 1 into log base 2 of 2. So our next log law states that if we have log base of something and in our brackets a number to the power of a number, that power or that exponent can actually come out the front so that it becomes that power, so in this case k, times that log. And we can do that in this problem because we have our x out the front. Basically meaning we can do the reverse of what happened here. That means is the same as log base 2 of 3 to the power of x, as we're bringing our x, which is multiplied by our log, and putting it in as our power. And we'll keep the rest of our equation exactly the same. And our next log law states that if we're adding two logs together and they have the same base, then we can turn it into one log with that base and multiply what's in the brackets. So we can see that we can apply this to our problem over here, as we have two logs with the same base and they're added together, meaning we can turn this into just one log to the same base, which is 2, and multiply what's in our brackets. So we have 3x times 2. And that's the same as 6 to the power of x. And now that we have log base 2 on this side and log base 2 on this side, these problems are actually the same, as all we're left with is what's in the brackets. So we can completely ignore our logs here and only focus on what's in the brackets. So we have 6 equals 6 to the power of x. And this works because we have log base 2 on both sides, and these are equal to each other, meaning what's in these brackets must be equal to each other, giving us 6 is equal to 6 to the power of x. And remember, we want to find out what x is, and just by looking at this problem, we can see that x is going to be equal to 1, as if we have 6 is equal to 6 to the power of something, what would make this statement true? Well, 6 to the power of 1 would be 6 is equal to 6, and 6 definitely equals 6, making x is equal to 1. We'll look at one more example just to ensure that you understand this. Okay, so now we're on to our second example, and I've left our log laws over here as we'll need them again. So for this example, we have log x plus log 3 is equal to 2 times log 4 minus log 2. So as I said earlier, when you are not given a base, it's just assumed that our base is 10. So we can go in and write all these bases in as 10. Next up, let's look at how we can start to simplify this so we can solve for x. Well, instantly we can see that we have 2 times log base 10 of 4, and we want to get rid of that 2 out the front. If you remember, that is this rule here. So if we apply that rule, that states that we can move whatever we're multiplying our log by and make it into our exponent up the top. So if we do that, we get log base 10 and then 4 to the power of 2. And the rest of our problem will stay the same. Okay, next up we can see that this first part of our equation is the same as our bottom log law, as both of our bases are the same with 10 and we're adding our logs together, meaning that we can put it as one log and multiply what's in our brackets. So if we do that, we get log base 10 of 3 times x, which is 3x. And over here we can see that 4 to the power of 2, well, that's the same as 4 times 4, which is 16. And there is one more log law that I will introduce in this video, as we have a log minus another log, both base 10. So this log law is very similar to the one up here, except this time we have 2 logs to the same base, except we're subtracting instead of adding. And that means that we get a log, just one log, to that same base, and instead of multiplying, it's dividing. So these two are sort of like opposites. So for this one, instead of adding, we're subtracting, and instead of multiplying, we're dividing. So if we apply this to this side of the equation over here, we get log base 10 of 16 over 2 as we divide what's in the brackets. So we have 16 divided by 2. And 16 over 2 is the same as 8. Now that we have 2 logs with the same base that are equal to each other, we can just take what's in our brackets. This means that we're left with 3x is equal to 8. And if we simplify that by dividing 3 on both sides, we are left with x is equal to 8 over 3. And that's our answer. Anyway, that's how you solve logarithmic equations. I hope you found this video helpful, and if you did, please consider liking and subscribing. See you next time.